Okay, sine and cosine graphs are always of the same basic shape. Sine always starts at 0. Cos always starts at 1. Alright, so this is sine, this is cos. There are a couple of things you need to know about. What an opportune time. This height here is the amplitude. Okay. I'm going to have to cut that out. I'm going to have to because you use their full names. That's a bugger. Alright, cut that. Start again. So this green height here is the amplitude. This orange distance here is called the period. Okay, so a period is one full cycle. So this graph will repeat exactly this, another one. Okay, so this distance is the period, this height is the amplitude. The same applies to the cos graph. That's the period. And this height here is the amplitude. Alright, so, sorry, yes, the amplitude is the highest point. Okay, a standard sine or cos graph is what you're looking at here. Okay, this height is actually 1. Okay, and the period is normally 2 pi or 360. Alright, so 2 pi or 360 is the standard period of a sine or cos graph. Alright, if you mess around with stuff, this is where it comes down to, okay, we've talked about transformations before. How do we apply those transformations we've talked about for quadratics and cubics and quartics, logs, exponentials, all those transformations we did, how do they fit into sine and cosine? Alright, so standard sine is y equals sine x. Standard cos, y equals cos x. Right? Where do you think amplitude goes? Okay. What normally happens when something is right at the end?
That's the axis.
That shifts it up and down, doesn't it? But does that multiply it up and down? Or does it just shift it? Right? It just shifts it up and down, doesn't it? It just changes that y-intercept. So
that'd be the amplitude.
So A for amplitude is out the front. Okay. Sine bx plus c. Okay. So this here is the amplitude. This here affects the period.
So is that how the graphs are wrote out, bx plus c?
Yeah, and plus c is actually outside. Sorry, I forgot to put the brackets in. Plus c is actually outside, and that you know shifts vertical.
Yeah.
All right, and cos is exactly the same. You just replace sine for cos. So A adjusts the amplitude. So if A is 4, then your amplitude is no longer 1. Your amplitude is actually up at 4. Okay. B affects your period. How does it affect your period? Okay. I'm so glad you're all so mature. Stop giggling, Miss Corbo.
I was giggling at Casey. She tried to make so she screamed.
Alright. So period is actually 2 pi on B. Okay, so if there's a number in front of your x, 2 pi divided by that will give you the adjusted period for that graph. And as I say, C just shifts it vertically. So to put that into practice, if we have a look at the graph y equals sine x, I'll do in black, and I'll do a graph of y equals 2, no, not 2, sine 2x in orange, and I'll also do a graph of y equals sine x on 2 in green. Okay, so I'll draw all three of these graphs on the one axis over here. So sine graph, where does it start? Starts at 0. Okay, so my basic sine graph goes here to 2 pi. Okay, goes up to 1, and down to -1. If I then draw sine 2x, it compresses this graph. So it's like a spring. This 2, my period becomes pi. So 2 pi on 2. Okay, so period equals 2 pi on b, which is 2 pi on 2, which is pi. I haven't changed my amplitude at all. Okay, so I'm still going to go up to 1, but I'm going to get this whole section of graph here, this one period of the graph, into this section here. Alright, so I'm actually going to go like that. Right, and it will continue. It'll do the same thing again. It'll go up. Okay, so it compresses it. Okay, you get twice as many in as you had before. Now, if we have a look at x on 2, that's a half. So period equals 2 pi on b, which is 2 pi on 1/2, which is actually comes out at 4 pi. Right? So what that means is in 2 pi, I'm only going to get half of my initial graph in. So I'm only going to get that part of the graph in. Okay? It will actually continue on for another 2 pi with this bottom section of the graph well off my page. Okay? So when you are sketching them, you start with your amplitude, you work out how high you've got to go, you then work out your period, and then you can sketch them. Okay, sine starting from 0, cos starting from the highest point.
When you did period 2 pi over b,
Yep.
where did you get b?
B is this number in front of the x.
Okay, so and the one underneath for the.
Is 1/2.
Yep, okay.
Alright.
So, Alfie,
Yep.
if your amplitude turned out to be negative,
Ooh, interesting.
show us
Yep, for sure. Yeah. So let's do some do some amplitude ones. So y equals sine x.
Shift the x-axis.
Yeah, that's what I was thinking.
Alright, y equals sine x we'll leave. We'll do y equals 2 sine x and y equals negative sine x. And we're supposed to do them in different colours. So let's choose this one to be red and this one to be blue. Okay, so if I draw a graph again, so my standard graph, okay, that's 2 pi, that's 1, that's -1. Okay, so 2 sine x, which is supposed to be in red, is going to come down here to -2 and up here to +2. I haven't changed my period. Okay, so I'm still going to get exactly the same amount of graph in that time. So I'm still going to go up, come down through that point, go all the way down and back up through that point. Right? If it was a half, which I probably should draw, let's draw that in purple. 1/2 sine x. Okay, that would actually do the same thing but only go half as high. Okay, what about negative though? We've talked about negatives before. What am I going to do here? If it's flipped, it's rotated around the x-axis, which means it's going to start at 0, and instead of going up, it's going to come down. So it's going to flip this black line, this black graph, it's actually going to flip that. So it'll come down here, up there,
So it's just
back
the
to there.
opposite.
So it's just
That's-
reversed over the x-axis, yes.
How come the blue one isn't negative?
Which blue one?
The first one.
This purple one,
Yeah. Okay.
that's a half sine x.
Oh, sorry.
Yeah,
just
sorry,
missed
yeah,
the
So I did that backwards. I should have done that a different way. So that's actually half sine x. So this only affects your amplitude. You can reflect it around the axis if you've got a negative sign there. All right. Make sense?
And that C at the end just moves it up and down.
C at the end will move it up and down. Yep.
Okay.
Doesn't affect your period. Doesn't affect your amplitude.
So,
All right. Your amplitude is still based off your center line. How high it goes from that center line, or how low it goes from that center line.
you still recording?
Yes.
Okay.
All right. Any other questions about that stuff so far?
Does the sign have to be sine? I mean, does it have to be sine?
No, this applies to cos as well. We'll talk about
Cos would be
tangents.
the exact same
Yep,
as
except cos starts at 1. So it
Okay.
starts here and goes back to there in 2 pi. Alright, so it looks like that guy there.
Okay.
Alright? So, when you are sketching the graphs, alright, it is important you do a couple of things. Okay, so that helps you find amplitude, it helps you find the period, it helps you sort of get a basic sketch. Alright, so here are some steps for graphing, sketching these. Alright, you got a basic type. Alright, which is basically sine or cos. Okay, that's the first step. Remember which basic type you're using, sine or cos. So start at 0, start at 1, la da 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 da. Find the period and amplitude. Right, which you know how to do. Period is 2 pi on b. Amplitude is height from centre line. Okay. Step 3 is to sketch one period. Okay, so you normally only have to sketch one period, so you sketch one period. Okay, so technically speaking, when I did this orange one, if I was only sketching sine 2x, I would only have to do up to pi. I don't have to go any further than that. Right, so you sketch one period. Part 4 is then to find x-intercepts. Now I haven't talked about that yet, so we'll revisit that in just a second. Or minimum and maximum. So, and min max values. Okay, and then step 5 is to do your translation up and down. Alright, so to put that into practice, we've sort of done it already. You choose your basic type, you find your period and your amplitude, sketch one period, find your x-intercepts we haven't done yet. Your minimum and max values are going to come from your amplitude, so that should be fairly easy. X-intercepts I'll revisit now, and then we just move it up and down depending on what they said. Alright, and then we might need to re-find our x-intercepts. Alright, but one thing I didn't explain to you when I was drawing the graphs is the x-intercepts. So let's do, what sort of graph is this? What graph is that one? Sine, good. And this one? Alright. I'll talk to you about what you just said in the second case, because, yeah, no, I'll explain where you got that from in just a second. Okay, we're not going to do tan today, that's another exercise. Alright, so this here, this value here, pi. Alright? Because it's half of my period of 2 pi. This value here and this value here, what do you think they might be?
Half pi and 2 pi and a half.
Pi and a half, yeah, 2 pi and 3. Alright, is normally how you would say it. Okay, so they're your standard x-intercepts for a cos and sine graph. So if we go back and have a look at this orange one, okay, what's this one here? Half pi. What's this one here? Pi and a half. 3 pi on 2 is a much better way of saying it.
On the other sheet you wrote it 2 pi on 3 instead of 3 pi on 2.
Oh yeah, sorry. Thank you. So 3 pi on 2. Sorry about that. So when you shrink or expand these, they expand proportionally. Okay, so this point here, the lowest point in a cos graph, in a standard cos graph, is always at pi. You cross the x-intercept, for the x-axis for the first time, halfway between your lowest point and your highest point. Your maximum value for sine is halfway between your start and where you cross the axis for the first time. Your lowest point is between where you cross the first time and the second time. So these proportionally do not change. So if your period is only pi, you can still proportion that out into 4 sections, and that's how you work things out. All right. So there are 4 sections to any graph, any sine, cos, and tan graph. Right? You got that section there, and that section there. All right. So you've got the first half where cos is coming down, sine is going up. Okay, and at the end of that section, something happens. Second section, end of that section, something happens. Third section, end of that section, something happens. Fourth section, you're back at the start, at the end.